Proving Theorems. This is lesson 2-3, and this is the start of what we call proofs and how you set up a proof. I'm going to go through two examples, and I'm going to try to keep consistent with moving this right along, but also trying to give you some detail on what are proofs and how you set up a proof. So let's start by let's write down this in your notebooks, and this is Theorem 2.1, which is called the midpoint theorem. And what the midpoint theorem says is if m is the midpoint, and if you look down at the diagram, so if m is the midpoint of segment AB, then a to m, the length am, equals half the length of the whole thing, and also the length of MB equals half the length of the whole thing. Now, what we're going to do is we're going to prove this, why this is true. So it may seem like a common sense thing, but we're also starting with a proof where it's going to be, where we're going to be able to lay out the proof and maybe help you understand how you set up a proof a little better by using kind of a common sense thing. So what I want you to do is in your notebooks, I'm just going to have you set your notebook up or set this example up exactly as I have shown on the screen. So what I have is I have a given statement, which is m is the midpoint of AB. That's what's given, because remember, the if part of an if-then statement is the hypothesis, or what's given. So if m is the midpoint of AB, that's what's given. Now the proof is we're trying to prove that AM is half the length of AB, and MB is half the length of AB. So you should have a given statement, you should have a proved statement, you should have a diagram, which I've shown in the red, which we can refer to, and then you have your two columns consisting of a statement and reason. Now, up to this point, the proofs that we have had already, quite a few of the statements and quite a few of the reasons were given. Now we're starting from scratch, so we got to actually take what's given here, m being the midpoint, and we got to show by a series of statements and being able to justify those statements with reasons that AM equals half AB and MB equals half AB. Well, how do we do this? And that's going to be the difficult part. So we're going to always start off our proof, and usually I said you start off a proof with what's given. So we're going to write down statement 1, m is the midpoint of AB, and that's given. Now, how can I get to that proof part? How can I get to this point? How can I use what's given? What do I know about the midpoint? Let's see, if m's the midpoint of AB, there is something that I know. I would know then that AM, the length of AM, equals the length of MB, right? Because if m's right in the middle, then that would have to be true. Well, how can I justify AM equals MB? Well, that's just definition of a midpoint. Right? So, now let's go to statement 3. So far I know that AM equals the length of MB. Now, how can I use that? Let's see, we're dealing with segments here. And what postulates or definitions have we had that deal with segments? Well, one that we've used quite a bit is the segment addition postulate. So let's try that. Notice how I'm going from one statement to another, just using the information that I've had above, in statements 1 and 2 to get a statement 3. Let's see, I know that AM plus MB add up to what? The whole length, AB. And why can I say that? I can say it because it's the segment addition postulate. All right, now, I've got a couple of statements now. I know that AM equals MB. I know that AM plus MB equals AB. Now, how can I use statement 2 and statement 3 to maybe get something like that? Well, again, that's kind of the challenging part. Well, let's see. How can I use statement 2 and 3? Well, I know that AM is the same as MB. So maybe I can replace this MB with an AM. So let's try this. AM plus AM, because AM and MB are the same, right? Because the statement 2 equals AB. And what I did here is I substituted. So the substitution property. So now, how could I use this? I think I'm getting closer to maybe something like this. So number 5, let's see, AM plus AM is 2 of those AMs, right? Little algebra equals the AB. And how did I get that? Well, it's the multiplication property. It's AM plus AM, or you could even say it's a version of the addition property. I didn't get too picky on that. Now, how can I get this? Well, if I divide both sides by 2, so in statement 5, if I divide both these by 2, I would get AM, because the 2's on the left side would cancel out, equals AB over 2, or half AB. And what property is that? I divided both sides by 2, so the division property. Now I want to go back, I'm looking at number 5 here. You could also say substitution on that. Remember that, that convenient substitution property where sometimes if you're not sure, you stick in the substitution property. All right, so what we have here then is I've proven this part right here. Now how could I prove the other part? What do you know about AM and MB? Well, you know that AM and MB are the same, right, from this? So substitute AM for MB, and you can say that MB is half of AB. Reason? Substitution. And what we've done is we've taken, I should say, 7 statements to come up what we wanted to prove. Now, you know what? This is probably the longest proof that you will see this year, but all it is an introduction to setting up a proof from scratch. So, we're given a statement, and we try to get to a certain goal or what we wanted to prove by a series of statements. Most of your proofs are going to be around 3 or 4 statements. They're not going to be quite this long. All right, one more. Let's write down theorem 2.2 now in your notebooks, which is called the angle bisector theorem. Now, instead of segment here, we're dealing with angles. So this one says if ray BX bisects angle ABC. So notice ray BX is cutting that whole big angle ABC, into 2 parts. Then, so in other words, that's what's given. Ray BX bisecting ABC. Then what we're trying to prove is that angle ABX is half of the whole angle, ABC, and angle XBC is half of the whole angle, ABC. So, in your notebooks, let's set up a 2-column proof, and when I ask you to set up a 2-column, what you need to do is have a given statement, a proof statement, a diagram, and also the 2 columns. So you may need to pause that and write that down. All right, let's start this. All right, so we're given that. So I've already written that in. Ray BX bisects angle ABC. Given. All right, how can I get maybe the hardest part of a proof, that second step? Where do I go? Where do I go to go from here to here? Well, what do you know about ray BX if it bisects angle ABC? Well, it cuts it into 2 equal what? 2 equal angles. So let's say that angle, I'm going to change that. The measure of angle ABX equals the measure of angle CBX. And why do I know that? Why can I say that? Well, definition of an angle bisector. Because what's the definition of an angle bisector say? It says that a bisector of an angle cuts it into 2 equal angles. All right, statement 3. Now, what else do you know about angles? What's that postulate that we've used also quite a bit? Let's see. From chapter 1, we had 2 major postulates, the segment addition postulate and the angle addition postulate. So let's use the angle addition postulate, maybe to see if we can get closer to our proof statement. So let's say that the measure of angle ABX plus the measure of angle CBX equal the measure of the whole thing, which is angle ABC. And the reason I can say that is the angle addition postulate. So I'm going to go up to my diagram and I'm going to mark those two angles. That angle equals the other angle. Now, where can I go from here? How can I use statements 2 and 3 to get us closer to what I'm trying to prove? Which is, we'll try to prove this part first, that ABX equals half of angle ABC. Well, let's try to use statement 2. We know that angle ABX equals angle CBX. So let's substitute in CBX. Let's substitute the ABX in right there, because they're the same, right? So let's say for statement 4, let's take statement 3, and let's say that measure of angle ABX plus the measure of angle ABX, right? Because I substituted ABX in for CBX, equals the measure of angle ABC. And why can I do that? Substitution. All right, statement 5. Kind of like the other proof, isn't it? Except we're dealing with angles. All right, what is, from statement 4, what is the measure of angle ABX plus the measure of angle ABX? Well, you have 2 of those measures of angle ABX equals the measure of angle ABC. And you could say addition, it's kind of a version of multiplication property. And just like we said before, I'll just say substitution, because ABX plus another ABX is 2 of them. All right, now getting closer, number 6, statement 6, how can I take statement 5 and get closer to this? Well, divide both sides by 2. So, the measure of angle ABX equals measure of angle ABC divided by 2, or half the measure of angle ABC. Reason, division, property. And notice now we have this statement, that the measure of angle ABX equals half the measure of ABC. Now, statement 7, we'll squeeze that in at the bottom. How can I get this? Well, we can simply substitute CBX, or excuse me, XBC. Is this the same thing as this? Is angle XBC the same thing as CBX? It is. It's just a different order. So I'm going to substitute the measure of angle CBX in for angle ABX, because these are the same, aren't they? And what's the reason? So ABC, let me rewrite that. So the measure of angle ABC. And the reason that I can do that? Substitution. So we've actually proven why this theorem is true with a series of 7 statements. Again, a longer proof, just like this one was, but we're slowly getting into how you prove theorems or setting up just an actual proof then.